امشي من عندك. Good day, viewers. You are welcome to this class. Good morning, guys. I appreciate everyone coming. Starting from Ademuyiwa Ezekiel. What's your name, please? Let me know who you are. Abdullah, you're welcome. Mariam, you're welcome. Rodia Allah. Is that Rodia Rodia? On God Graphic Design. I don't know what it is. You're welcome as well. Salaudin Mazida, you're welcome. Akindoni Akinade, you're welcome. TT, you're welcome. Adegbit Orodia, you're welcome. Thank God we did not go today. You're sending me a message. So, yes, just starting. So, probably you don't hear anything before, but I believe you should be able to hear something now. You can hear me now, please signify. And for those that are probably late, so please let them know the class has started. So today we'll be putting permutation and combination together with Ezekiel. I can't recall, but Ezekiel, you are welcome. So for those who have left, let them know that the class has started. Yes, let them know that the class has started. So we'll be running through two topics. And I think that yesterday we did a lesson on how to find maximum and minimum point of a trigonometrical function. So I told you to substitute the maximum and the minimum value of the trigonometrical function there. They are sine a particular angle or cos a particular angle. Then you check that that one that is higher will be the maximum value and the one lower will be the minimum value. So a quick revision on what we did yesterday. For example, we have to find the find x marks of theta. If f of theta is equals to 4 over, let's say, 2 minus 3 cos theta. Let me put 2 here. So I told you that you have to substitute. Recall that cos theta ranges between minus 1 and what? And 1. So substituting minus 1 for cos theta here, you have 4 over 3 minus 2, open bracket, minus 1, and that will be 4 over 3, minus 2 times minus 1, that will be plus 2. You have that to be 4 over 5. Substituting 1 for cos theta here, that will be 4 over 3 minus 2, open bracket, 1. You have that to be 4 over 3 minus what? 2. That will be 4 over 1, which is what? 4. Since this one is giving us a lower value compared to this one is giving a higher value compared to this, so automatically this one here is the maximum value, while this one is what? Minimum value. So I will have to find f max of theta. Automatically that will be what? That will be 4. Okay. So let me know, show me love, let me know you are. You can see I'm putting on cardigan today. Let me know you are here. Graph of sine, cosine, and also tangent. I told you that of sine, it will always migrate from the origin, and it was right. Okay, I told you that. Yeah. When it is passing through the origin, it goes out together. That's for positive sign. If it's negative side, it will work. I did not tell you that yesterday, but I believe you guys can see, like you can see now. Please try. You guys can see, like you can see now. So try it again. Let me tell others how it is working now. If you can see, let me know. Please signify before I will continue. Before any family will tell me again that no master, I don't understand. If it is clear now, if the network is good. I said confirm now if it is showing well now at your side. Everywhere is still blur. Then maybe you should switch on your airplane mode and try it again. Or you change your position. Try changing your position. It is not that clear. Then it is your what's it called? Your own network per se now. Change your position. You can just move a little bit. Please, for those who are just joining, if you can see the board, if you can see me, let me know. If you can see me, let me know. Please, if you can see, let me know. It is showing now. Okay, thank you very much. On God graphic design. Thank you very much. I really appreciate that. Okay. So as I was saying, I said you have to do the concept of sine to get your sine 75. Now is sine 30. This is 1 plus 2 cos 45, which is root 2 over 2. I believe if any is here, you'll be able to get this now. So I'm glad you said that your three that of tangent, I will quickly brief that. Plus cos 30 is what? Root 3 over 2. Multiplied by sine 45, that's root 2 over 2. So you notice that we have two terms here. So looking at the numerator and the numerator here, what do they have in common? I'm trying to factorize. The what? Root 2 is common over, look at the denominator, what they have in common? Both 2. So that means they have 2 times 2 in common, which is what? 4. But let me write it in form of 2 multiplied by 2. For those people that will not get it easily. What I have left in this bracket is 1 plus the plus you have. What they have left in this bracket, that's root 3. And this 2 times 2 becomes what? 4. That is what you have here. I hope you understand that now. And you may not have it in this one. You may have it in this form. This one will be root 2 over 4 plus what? Root 6 over 4. You may have it like this. So it is still the same thing. It is still your sine 75. And I told you that sine 75 will be equal to cos 15. Why is it like that? Because this 75 and this cos 15 are complementary. I told you sine of an angle is equal to the cos of its complement. So sine 75 is equal to cos 15. And which they are both what? Root 2 over 2 in bracket 1 plus 3. Okay? So note that if this one is then it will be addition. And if it's subtraction, it will what? Subtraction. Now let's do that of sine 15. Okay? Let's see what sine 15 will give us. sine 15. 15 should be gotten by saying 45 minus 30. Yes. Okay? Now it is still sine, so you have to use the shin co-shin. So you see, sine 45 cos 30. But since this is minus, this one here will what? Minus. Then cos 45
Sine 30.
sine 30. So we have sine 45 to what? Root 2 over 2. Was cos 30 to what? Root 3 over 2 minus cos 45 to what? Root 2 over 2. And sine 30 should be what?
1 over 2.
1 over 2. Now look at the 2. You have what in common at the numerator? 2. And you have what in common at the denominator? 4. What do you have left here? Root 3. What do you have left here? 1. So automatically our sine 15 is what? Root 2 over 2 in bracket root 3 minus 1. So that is what I said here. That we have some options to be like this, that it is root 3 plus 1. It is still the same thing as what I did here. Still the same thing. It's commutative. A plus B is equal to B plus A. There's no change. Okay? But as for this one, you cannot interswitch this. It will give you another it's another thing entirely. You get that now. So 15. And sine 15 will be equals to, what's the complement of this thing? 75 is equals to 75. Okay? So and that is what? Root 2 over 4, open bracket, root 3 minus 1. Do you get that now? Okay? So what you there's this okay, let me just move to that of course. Explain that of course, move on to that of tan, explain that of tan, then move on to space topic. But okay, let me just move on to that. So if it is cos x plus y plus or minus, depending on what you have. For cos should be coco shin shin. Coco shin shin. Coco shin shin. So about cos x cos y. If this is plus, this will be minus. If this is minus, this will then be what? Plus. Eh? Can I say I'm writing minus here first? But when this one is plus first. And when it is minus, this is what? Plus. Coco shin shin. You get that now? So we have to find cos 75. Cos 75 should be that's 45 plus 30. No, we already know cos 75 already. Yes. This. So let's try this and see. Let's check what we get. Coco shin. How the cos 45 cos 30. I told you it is plus
Minus
sine 45
sine 30.
Sine 30. So cos 45 is what? Root 2 over 2. Cos 30 is what? Root 3 over 2. Minus this one is what? Root 2 over 2. And this is what? 1 over 2. What do you have in common? Root 2 over 4. What do you have left? Root 3 minus 1. You can see that is what we have here.
Yes.
So that is to tell you that your cos 75 is that. Okay? I'm trying that of cos 15. We already know our cos 15 also to be sine 75, which we got earlier. So let's try doing that. I believe this one is clear for those who are following me. Please, if it is clear, let me know. So what if what we're asked to find is cos 15. Cos 15, cos 15. Now you know that 15 should be gotten by saying 45 minus 30. Now everything we'll be using should be a special angle that you know its value.
Yes, sir.
So I use 45, 30, I use 60, I use 90, those ones that you know their value. Okay? So cos 15 should be what? That's what? Cos 45. 45 minus what? 30. Okay. Cos 5 is a special angle. 30 also is a what? Special angle. Now using the concept of cos, I'll be that's cos 45, cos 30. If this is minus, then this will be what? Plus. Sine 45 and what? Sine 30. Okay? So cos 45 is what? 2 over 2. 2 over 2. Cos 30 is what? 3 over 2. Plus cos 45 is what? Root 2 over 2. Sine 30 is what? 1 over 2. So we have that. What they have in common? They have root 2 over 4 in common. Yes. So it means what? 3 plus what do you have left here? 1. And so that it is equal to what we had here earlier. So I say that your cos 15 is equal to your sine 75 degrees. Okay? So just try to remember your shin, ko, shin, and your koko, shin. Please, can help me share the live stream to your status and everywhere you know you can share it to. Where you have your colleague preparing for what's it called, UTM, just 26 UTME. Let them join class. Let everybody enjoy it together. Share, and keep on liking. Thank you very much. So moving on. For time. Yes, for time. Now, earlier I told you that tan is equals to what? Sine over cos. Yes. So I will quickly go through that one. I don't want people to start asking questions like that. Though the formula I can just give you, I want to show you something so that for those who don't know, will be able to know better. So this one will be sine x plus or minus y over cos x plus or minus y. Okay? So what's our sine x? Sine x plus or minus will be what? Shin shin sine x cos y plus or minus cos x sine y all over. For this cos it will be shin cos x cos y minus or plus, okay, sine x sine y. Now let's factor out cos x cos y from each one. Okay. So meaning we're dividing each of the term by cos x cos y. So this one here becomes sine x cos y over cos x cos y plus or minus cos x sine y over cos x cos y. So I'm dividing each one by cos x cos y all over this one cos x cos y all over cos x cos y minus or plus sine x sine y all over cos x cos y. Okay? This cancel this here, this cancel this here, this cancel this cancel this. You have one left here. So what do I have now? How about tan x plus or minus y to be? Now what do I have left here? Sine x over cos y. And sine of an angle over because of the angle becomes what? Tan of the angle. That's tan x plus or minus. Sine of an angle over cos of the angle is what? Tan of the angle, that will be tan y. All over. What do I have left here? Nothing. That will be 1. Okay? Minus or plus. Sine of an angle over cos of the angle is what? Tan of the angle. Tan x. Tan of an angle over cos of the angle is what? Tan of the angle. Let's say that your tan x plus or minus y. You tan x plus or minus y. The way you have it is what you have here. You have plus here, you have plus here. You have minus here, you have minus here. Okay? Then 1, if it is plus here, it will be minus here. If it is minus here, it's what? Plus tan x tan y. Okay? So that is that. But most of the time, I will employ you not to deploy this one. Just say your what? Your sine value over the what? Cos value. You get that? Sine of the angle over cos of the angle. So if we are asked to find tan, let's say 75 now, you should not bother yourself. Just say what? Sine 75 degrees over what? Cos 75 degrees. What do we have as our sin 75? Our sin 75 is what? Root 2 over 4 multiplied by root 3 plus 1. Okay? All over. What's our sin 75? Our sin 75 is what? Root 2 over 4 multiplied by root 3 minus 1. You know that this one cancels this, okay?
Yes.
So that means that tan 75 degrees is equal to root 3 plus 1 over root 3 minus 1. And this is a particular historical expression that you have to rationalize the denominator by multiplying both numerator and the denominator by the conjugate of the denominator. So what's the conjugate of root 3 minus 1? That's root 3. Students often get it wrong when it comes to getting conjugate of logical expression. Now let me start with this. Let's say we have root 2. So if you are being asked that what is the conjugate of this, it means that this thing is a sort. We call them irrational numbers. They are radicals. Okay? Irrational numbers. You cannot express them. Their decimal form cannot be expressed in form of a over b. Okay? So that is why we call them irrational numbers. Now, when we say conjugate of it, what can you multiply by this root 2? The number that you multiply by this root 2 for this thing to become rational. A number, a value to multiply by this for this thing to become what? Rational. A rational number. I know that this root 2, it means 2 raised to the power of 1 over 2. Okay? It means what? 2 raised to the power of what? 1 over 2. Then what should I multiply by this to make it a whole number? So let me just say times 2 raised to the power of what? 1 over 2. Because I know that according to the law of indices, when you have this x is square a times x is square b, it becomes x is square a plus b. So this one also becomes 2 raised to the power because the bases are the same. 1 over 2 plus 1 over 2, and it becomes what? 1. That's 2 raised to the power of what? 1. You can see that 2 raised to the power 1 is now what? Whole number. That is irrational number. So that is why the conjugate of root 2 will be what? Root 2. Do you get that now? So that's one, the parts. Another thing is that what if it is 2 root 3? What's the conjugate of 2 root 3? This one here, just say that since it is still a monomial, you see what is the conjugate of this? You then pick only the sodical part. The sodical part there is what? Root 3. So the conjugate of this will be root 3, not 2 root 3. Okay, the conjugate is what? Root 3. If you are using 2 root 3, you are only making work complex for you. So it just the what? The sodical part. The conjugate of 3 what? Root 2 root 3 what? Root 3. Just that. But if it is binomial, probably you have root 2 plus root 3. Okay? What will be the conjugate of this? The conjugate of this is what? Root 2 minus root 3. We change the sign now. You do what? Change the sign if it is binomial. Okay? You may now be having probably 2 root 3 minus 3 root 2. Now see that this one 2 is still what? Binomial. What would then be the conjugate of this? You may be thinking that should we use this 2 at the back and this 3? Yes, you have to use it. Because this one is not what? Monomial. It's not just one. So you have to say multiply by the conjugate to what? 2 root 3. This minus here becomes what? Plus 3 root 2. Do you get that now? So that is the what? The conjugate. The conjugate is getting that. Note that it is what? Monomial, just one. You pick this up, part. But if it is binomial, it is the entire thing that you write. Only that you change the what? Sign. Okay? So the conjugate of this root 3 minus 1 will be what? Root 3 plus 1. Tan 75 equals root 3 plus 1 over root 3 minus 1. So the conjugate is what? Root 3 plus 1. So you put the conjugate up and down. Okay, this is the conjugate of this. Okay, so multiply find this, a good math student should know that this and this are the same thing. Just like saying x times x. X times x will be x squared. Just like saying b times b times b will be b squared. So root 3 plus 1 times root 3 plus 1, that's what? Root 3 plus 1 squared. So, yes, some of you will start multiplying like this, but I don't want to do that because I know that they are the same. So I love using the concept of whenever you have this, square of binomial, it becomes the square of the first one plus the square of the second one plus 2 times the product of the two terms. The square of the first term plus the square of the second term plus 2 times the product of the two terms. Over this one here also is difference of two squares. So whenever you see that you have a particular term, okay,
it's closer here.
so whenever I see two terms, okay, multiply by probably another value, but the sign is different. This one is plus and this one is minus. Probably this one is minus and this one is plus. It becomes what? When you expand, what you get is the square of the first one minus the square of the second one. Or that one, difference of two perfect squares. You have it in this one too, you can write it back in this one. So probably you have a square minus 4. Because this 4 is the perfect square, and this a also here is what? Perfect square. It becomes what? A square minus 2 multiplied by a plus 2. Okay?
Yes.
This is the perfect square, this is the perfect square. And the relationship between them is what? Subtraction. A minus 2 multiplied by what?
A plus 2.
So now is just by the way to explain the concept behind this. So we'll say this one here is the perfect square, that will be 3, the square of the first one. 3 square minus 1 square. And to expand this, I will use this concept here. The square of the first one, that's 3 square, plus the square of the second one, that's 1 square, plus 2 times the product. The product of 3 and 1 is what? 3. Over this one cancel this. You have 3 minus 1. So this cancel this as well. That's 3 plus 1 square is 1. 3 plus 1, that's what? 4 plus 2 root 3 over 3 minus 1, that's what? 2. And then factor out 2 here. 2 open brackets. 2 is common here, and 2 also is common for this term. Okay? Yes. When you bring out the 2 here, it means 2. When you bring out the 2 for 2 root 3, it means root 3 over what? 2. So this cancel this, and that's what? 2 plus root 3. And that is that. Okay? That is that. Note that 75 is 2 plus root 3. Please, if you understand, please send likes. Let me know you are with me.
Master.
Which part do you not get? Please, give me which part do you not get? Please let your respond fast. Which part do you not get? Keep on liking as you are watching. At any point in time, I explain anything you get or you don't know before that you not get. At that point in time, press your like button.
From 75.
Damn, that's from the beginning right now, guy. Okay. I told you tan is what? Sine over cos, right? You should use that concept instead of using the concept of this one. I feel like this one will be safer. Using the concept of that tan for an angle is equal to sine of that angle over cos of the angle. So that's why I use it instead of using this concept here. Okay? So sine 75 over cos 75 is our tan 75. And we knew our sine 75 earlier. We've gotten that to be what? Our sine 75 is what?
Root 2 over 4.
Sine 75 is root 2 over 4 over root 2 plus 1. And cos 75, this is it. Root
Root
over
over
4
4
in bracket
bracket
root 2
2
minus
minus
1.
1.
That is what I wrote here. Then this one cancels this. Then you have this one left. And that is how you have solved. Then you rationalize the denominator by multiplying both numerator and denominator by the conjugate of the denominator. The conjugate of the denominator, this root 3 minus 1 is root 3 plus 1. I told you, you just change the sign.
Yes.
Since it is binomial. Okay, what if it is trinomial? How do you do that? When we get to solve, we'll talk more about that. When you have the denominator of a soluble expression to be trinomial, okay? So we then rationalize the denominator, multiply this. I told you this and this are the same, so I swear it. If you know you cannot do it that way, just say with 3 times you have what? 3. With 3 times 1, that's plus with 3. 1 times with 3, that's plus another with 3. 1 times 1, you have what? 1. 3 plus 1, that's what? 4. With 3 plus another with 3, that's how many with 3? That's
2 root 3.
2 with 3. So that is how I have this. Okay? And for the denominator, it's the difference of 2 squares. You don't need to start like expanding. You are a jam student, you want to write it here. So those things are what you should know. Just say the square of the first one and the square of the second one. Why is it like that? You have the same quantity, only that the signs are different. Okay? So you say the square of root 3 minus the square of 1. Square of 3, square cancel roots. 1 square is 1. So 3 minus 1, 2. So here I factored out what? 2. Factoring out 2, from this 4 it remains 2. From this 2 3 it remains root 3. And this 2 under cancel this 2. You cannot just use this 2 to cancel this 4 and leave out this one alone. The relationship there is what? Addition. And if it is multiplication, you can say that, but it is addition, so you cannot just use this 2 to cancel only this 4 and leave this 2 with 3 here. No. It will be very wrong doing it that way. So the first thing you do is that you factor out 2, okay? Then you write out what you have left. Now, the relationship here is multiplication, that is why I'm able to count. But here it is addition, I cannot do that. So be very careful, okay? So I believe it should be clear now. If I may please. Do you understand? So moving on to that question that Jam gave you, saying you should find tan 15. Tan 15. In your mock. Yes, I got the information from most of my children that did the mock. That you're giving question on tan 15, but they know it. Okay? Thank God they know it. So if there's anybody here that don't know it, please pay attention. Tan 15, you should know that it's what? Sine 15. It is a very simple one. Imagine Jam is giving you this kind of question. Can never be me. Cos what? 15. Okay? Sine 15 will be what? Sine 15 over what? Cos 15. So what's my sine 15? Sine 15 is what? Root 2 over 4 in bracket root 3 minus 1 all over my cos 15 is what? Root 2 over 4 in bracket root 3 plus 1. Okay? This cancel this, and that's what? Root 3 minus 1 over root 3 plus 1. Then you rationalize the denominator by multiplying both numerator and denominator by the conjugate of the what? The denominator. So what's the conjugate of root 3 plus 1? That will be what? Root 3 minus 1. So I'll say root 3 minus 1 multiplied by another what? Root 3 minus 1, which is the conjugate of the denominator, and root 3 plus 1, what I have at the denominator earlier, multiplied by the conjugate of the denominator. So this one here is what? Perfect square, meaning it is root 3 minus 1 square. So I'll say it is the square of the first one, which is 3, plus the square of the second one, minus, why is it minus? Because it is minus I have here. Minus 2 times the product. So what's the product of 1? That's what is root 3 over. This one is difference of 2 square. I told you when you have the same entity, only that the signs are different, it is difference of 2 square. Those points, you need to note them. And at your own or on your own, you can easily form questions that look like this and keep on solving them. So the more you solve, the more you get to know it better. The more you get to remember at any point in time you come across those kind of patterns by solving certain questions. So this one will be what? 3 minus 1. Okay. So moving on to the other side. told you can only use this 2 to cancel this 4 because the relationship there is not multiplication.
Sure.
And you have to factor out 2 minus
I'm trying.
3 over 2. This cancel this. And that is 2 minus
root 3.
So that's telling you that your term 15. The question jam gave you in the box. The answer is 2 minus
Root
3.
3.
So it is as simple as that. So please pay attention. Let's get to work. Huh? And then, okay, let me explain the concept of tan graph that Roger asked. So you guys also should pay attention. Now, what I said about tan graph is that the periodicity of sine and cosine is 316 over the coefficient of what? The angle, the variable you have is sine. Probability is sine mx. So it will be 360 over what?
M.
That of course also is still 360 over
Yeah.
But if it is tan, it will not be 360. It is what? 180. I don't know. I don't think I remember to tell you that. And also I want to say this, that okay, sine theta, I think I talked about this because of sine 180 minus theta. I think that talks about this. And cos theta is equal to minus cos 180 minus theta. So whenever you see this, you should know that it's negative of this. When you see, yes, when you see this, it's negative of this. Okay? And for tan 180 minus theta, because this one has already, it falls on the second quadrant, and it is only sign that will be positive. That's why this one is positive. Cos and tan will be negative. And you should always remember your reciprocal. The 1 over sine theta is what? Cosec theta. Do not forget. 1 over cos theta.
Sec.
Theta was sec. Because this question, where you have tan here, it may be caught that the real jam will then ask from you. And 1 over tan theta is what? Cos theta. So if it is caught that the real jam asks, it would have been what? Cos 15 over what? Sine 15. You get that? So be very careful when you're doing that. Yes, I want to talk about you having sine 90 plus theta. Sine 90 plus theta. Sine 90 plus theta. Sine 90 plus theta is equal to sine 90 minus theta. Sine 90 plus theta is equal to what? Sine 90 minus theta. And sine 90 minus theta is equal to cos theta. Because this one is a complement. Okay? So, and also if you have cos 90 plus theta, is equal to what? Minus. Is equal to cos what? 90 minus theta. Do you get that now? It will be negative because it has already exceeded what? 90. It's no more in the first quadrant. So, and you know that cos of a complement is equal to sine of that angle. Okay? So that's minus sine theta. Get that now. So whenever you see that, you should always be careful. I actually want to explain the graph of tangent. Okay? So let me rub this one off. Okay, let me come back. So for tan, well, for tan, yes, it is passed through the origin like this. Know that it passes through the origin. It intercepts the y-axis at 0. Okay, so it is asymptotic to where your what? Your theta is equals to 90, 270, 450. So if we should express all this in radian form, this one is pi over 2, that's 1 pi over 2. This one is what?
3 pi over 2.
and this one is what?
5 pi over
5 pi over 2. So that means the point at which this curve will be asymptotic to a particular vertical line is when it is, the general formula for this should be 1 over 2 pi open bracket 2n minus 1, because all these values 1, 3, 5, they are odd numbers. So formula for odd number is just 2n minus 1. Then remember you have over 2 over 2. Okay? So at the point where the theta is what? Is half of pi. Is what? Odd multiple of half of pi. Do you get that? Odd multiple, that is 1, 3, 5. Multiple of half of pi. Then at that point it is asymptotic. It should not, the curve should not because it is infinity. Remember that 90 is what?
Infinity.
Undefined, yes. We don't know the exact value. Do you get that now? So that means it is a very large value that we don't know the exact value. We are not sure of the value. So very careful. And again, it will now intersect with your x-axis at theta equals 0, 180, 360, thank you, 540, and so on like that. So that's, this one is what? 0 pi, 1 pi, okay, 2 pi, 3 pi. So this one is multiple of what? It's pi. Okay, so this one here is pi over 2. Let's say this one here is what? Pi. This one here is 3 pi over 2. This one here is what? 2 pi. Let's say this one is what? 5 pi over 2. And this one is what? 3 pi. So note that we are at the point where it will be asymptotic. This one and this one. And we already know that. Okay, the next one, let me put it here. This one will be 7 pi over 2. It is also asymptotic here. So we know that it will what? It will intersect the x-axis, the theta axis, at this pi, 2 pi, 3 pi, and also 0 pi as it is here. Okay? So we are drawing another one to start from the ground. It will intersect here. We need to go like this. Okay? It continue with that pattern. Okay? It continue with that pattern. How the graph of tan theta look like? This f of theta.
Okay, no.
Why this is what? Theta.
Theta.
Okay, I think with here. Is it clear now?
She's online now.
I think with here. Is it clear? Okay, thank you very much. Some people are saying that is if you are online and you already showed them that you're online. Thank you for showing them. I really appreciate that. Okay. So I feel like that's the end of trigonometry. Imagine you made me use 3 classes to explain trigonometry. Imagine it's quite unfair. It's unfair.
Asymptotic.
So please pay attention for starting permutation and combination. I told you guys that if you have any question regarding the topic I've treated or the subtopic I've touched, make sure to bring question to the group and let's solve it together. So permutation first before combination. So even before permutation, I'm supposed to talk about factorial. Whenever you have factorial, this is symbol, or you have it like this. If I say n factorial, this is still n factorial. And what does it mean? Okay, it is the product of the counting number, the natural number, up to that value you have. If I say 1 factorial, what's the natural number? Natural number starts with 1, that's 1. Up to that number, it's already up to it. 2 factorial, multi-product of 1 up to this thing. The next one is what? 2, and that's all. 3 factorial will be 1 multiplied by 2 multiplied by 4 factorial will what? 1 multiplied by 2 multiplied by 3 multiplied by 4. You are not meant to jump anything. Do you get that now? All these things here now, you can still rewrite them from the back. It can be 2 times 1. This one can be what? 3 times 2 times 1. This is what you will have learned in your class. 4 times 2 exactly. So probably we then have, let's say, 6 factorial. That what? 6 times 5 times 12 times 3 times 2 times 1. I see that I'm trying to get to 1 before I stop. Okay?
Yes, yeah.
But as time goes on, probably I did not want to get to 1. I want to stop at a point in time. Let's say I have 7 factorial. I want to stop at 4. Okay? So I would then say 7 times 6 times 5 times 4. That just like this one. No, I want to put what? Factorial. Why is it like that? I've not gotten to 1. If I should get to 1, there's no need for putting what?
Factorial.
They get that now?
Yes.
And also note that 0 factorial is 1. Note that 0 factorial is 1. You should know all this one offhand. 1 factorial to be 1, 2 factorial to be 2, 3 factorial to be 6, 4 factorial to be 4, 5 factorial will be what? Let me write it down here. 5 factorial. This one times 5 is 120. Okay, 6 factorial should be 720.
Yes.
Okay, so you should know it. If you can know it up to 10, it is okay. Okay, so that's for factorial. Yes, you can also have it like this. Right, believe Jam cannot use this, cannot give you this symbol. Because I feel like a lot of people may get it wrong. Okay, so moving on. Concepts of factorial is the principle of counting, of arranging objects or items, taking certain things at a time. I'm already relating it to permutation. But before then, let's take this. In how many ways or how many numbers? How many 3-digit numbers? Let's go down. How many 3-digit numbers are there? How many 3-digit numbers are there? Okay? So we'll say like this. I'm drawing this. For numbers, we have how many digits? We have 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you should say 10, 10 is already the position of this. Okay? We have 10 digits. Okay? 10 digits, including 0. So, for we to have 3-digit number, for it to be 3-digit number, this first thing cannot be 0. Everybody knows. Once if we say 0, 1, 2, he is already 2 digits, that's 12.
Yes.
Okay? So 0 cannot be here. But 0 can be here, 0 can be here. Note, 0 cannot be here. For it to be still be 3-digit number, 0 can't be here. Do you get that now? So, how many options is this one having now? Because 0 cannot be here. How many options is this thing having?
9 options.
So 9 options. Okay? 9 options. Good. Multiply by. And this one is having how many options?
8 options.
0 can be here. Okay? 0, I did not say repetition is not allowed.
Okay, repetition is 10.
So, even looking at the question, that means repetition is allowed because I only said 3 digits. Do you get that now?
Yes.
How many 3 digits are? How many 3-digit numbers are there? Okay, so this one here, it has how many options? 10 options. So it can take any of these 10 digits. It has 10 options. Okay? Multiply by, and the last one also cannot take how many digits?
10.
10. It has 10 options. So how many 3-digit number do we have?
900.
That's 9 times 10 times 10. Okay? I believe that one is clear. Please, I believe you are following me. Need first time what again? Don't just be telling me you don't understand. Pay attention to what I'm explaining now. Guy is late. No, don't tell me yes, sir. Which part you don't understand? Make sure you focus on what I'm saying. Guy. And focus now. It is simple, exactly. I've not even done anything. I only explained that zero cannot be here. Zero cannot be here. Zero cannot be here. Remove the zero. How many digits can you put here now? 9 digits. Then here, zero can be here. How many digits can you put here? 10.
Yours.
How many digits can you put here? 10
10.
again. So multiply 10, 9 by 10 by 10.
9 by 10 by 10.
Understood.
9 is by 8.
It's not something too difficult. Please, if you are following, let me know. Please keep on liking. Bernard, you are welcome.
You always sleep the good life first. Hey, Jesus.
Okay, moving
Who
on.
is the channel? Okay.
What if it is something like this? There are 6 vacant seats. In how many ways can 3 people sit on them? In how many ways can 3 people sit on the seats? So we say we have 3 people. Okay, we say we have 3 people. And the first person has how many options? He has
6
options.
Yes.
Is either he sit on the first one,
Or
or he sit on the second one, or he sit on the third one, or the fourth one, or the fifth one, or the sixth one. But as soon as he sits on one, automatically the option the second person has is reduced to what? To 5. If you please focus. As soon as the first person sits on one of the 6 seats, the option for the second person reduce to what?
5.
Now if the second person also take another seat, how many seats do the third person have left that he can sit? 4. So that would be what? 6 times 5 times 4.
120.
So that is what? 120 ways for the 3 people to sit on the seats. Do you get that now? It's as simple as that. Follow me. I want to hear from Pharaoh. Do you understand? Sorry. Nífẹ̀ẹ́ mi. Not fẹ́ràn mi. Nífẹ̀ẹ́ mi. Nífẹ̀ẹ́ mi. Do you understand?
That's it. The second person have 5 options. I thought it was 6. If you sleep when you fly. Yes.
Okay, moving on.
Yeah, I can hear you there.
Moving on.
It's okay.
Okay, what if it is probably 3-digit number can be formed using the digits 1, 2, 4, 5, and then 6. How many 3-digit number can be formed using the what? The number 1, 2, 3, 4, 5, and 6. 1, 2, 3,
4, 5.
1 to 4,
1 to 4.
5, 6.
And
Yeah.
say
Repetition is not allowed. So that means you cannot repeat any digits. Now look at what to form 3 digits number. Okay. So we have how many options here? We have 5 options. You get that now? It's just like what I explained the other time.
Yes.
Now we have 6 options. Okay. But here we have what?
5 options.
So the first number can be any of those 5. Do you get that now? Recall that there is no repetition. Any number we use out of those 5 cannot be repeated. So that means the second space, do you get that now? Has how many options?
4.
And the third one has how many options?
3.
3.
This is as simple as that. So it's about 60 or 60
Numbers.
If it is clear, then let's be fast. So let me continue.
Okay.
Oh, you can't hear me clearly? I feel like it should be your network. I feel like it should be your network. You can just change your position, or you try to get earpiece, or probably headset. Okay, let me continue. Thank you very much.
So what if you have question like this? Okay, let me touch this question. How many number? Yes. How many number can be formed? How many numbers can be formed using the digits 1, 2, and 5? Using the digits 1, 2. Okay, good. I've changed the question. Repetition is not allowed. Also, how many numbers can be formed using the digits 1, 2, 4, and 5? Repetition is not allowed. Now here I did not tell you the number of digits. So definitely it can be 1 digit, it can be 2 digits, it can be 3 digits, it can be 4 digits, but can it be 5 digits? No. Why? Because I only have what? 4 digits. So either it is 1 digit number, 1 digit, or 2 digits, 2 digits, or 3 digits, or 4 digits. And all in logic, or let's say in set, it means what? Addition. Yes, it means addition. That means after doing that of this, we add it to that of this, we add it to that of this, and that of
that.
So starting with the first one for 1 digit. 1 digit. How many options do we have here?
Oh.
This one just has 4 options. That's 4. Plus for 2 digits. This one has how many? The first one will have 4 options. But the second one will not have that same 4 options because the repetition is not
Allowed.
I think the repetition is allowed. It should have been 4 again.
Yes.
So you just say
Times 3.
Times 3.
Okay?
Plus
for 3 digits.
4.
This one will have 4 options.
Times 3.
This one 3 options.
Two.
And this one 2 options.
Plus
42.
4,
3, 2,
3, 2, and what? 1.
Yes.
So we'll have this one to be 4.
4 plus
We'll have this one to be 12.
plus 24
We'll have this one to be 24.
Plus
plus
24.
24.
So add everything up.
64. 64.
Huh?
64.
64 numbers. If you understand, please signify. Let me know you understand.
I understand. She want the TikTok now.
Because my fellow.
Why? Oh.
You have not reached the limits. Not at a time of age.
Isso go for me. Don't phone me.
Someone is suggesting I use TikTok. I don't know. It's a suggestion that I use TikTok. But what happened is that I cannot go live on TikTok because I'm still on 683 followers, I think, yes. So until I have 1K followers. So I still need about
300
what is that?
27.
Yes, 300 more people. I don't know if you can get me to 1K followers. If I'm able to reach 1K followers. Yes. If I'm able to reach 1K followers, I'll be able to do live. I feel like TikTok, what's it called? Live will be better, yes. Yes, it will be better. It is also Matt Arc, yes. Matt Arc.
100%.
Arc. Or you check for Adishiri Sulaiman. On TikTok, so help me. You can help me get more followers. So instead of this one, TikTok would have been better. The way you guys are shouting, you are saying that it's not clear, it's not clear, it's not clear. So it would have been clearer. Yeah. So can I move on? If I can move on, let me know. Can I continue? If I can continue, let me know, please.
Continue, please.
Okay, thank you, Abibi.
Abibi, hope Abiba too will not be annoyed that you are awake at this point in time. I don't know the person. So okay, let's take this question also. Okay, let me move to permutations, please. Like that. And we'll continue to solve questions. So once the permutation is talking of the number of ways R item can be, N item can be taking R at a time. Permutation is talking about arrangement. Okay? The arrangement of what? Certain item, taking a particular number at a time. You know, we can actually have, let's say, 5 people. Are you now?
Yes.
And we're only taking 3 out of them. Are you now? In how many ways can we arrange these 5 people taking 3 at a time? It means we're only arranging 3. We are only arranging 3 out of these 5 people, not all the like 3 at a time. If we want to arrange, okay, we take 3 people, we arrange. Take another 3 people. Like, in how many ways can you arrange 5 people taking 3 at a time? Do you get that now?
Yours.
So that's the meaning. So what do we do whenever we have this case of what? N permutation R? It's very simple. What you just say is that you say N factorial over N minus 1 of factorial. So me, I used to tell my student. I used to tell my student that you don't stress it. It is jam. Know this formula. Yes, jam can ask you, and just give you 5 permutation, or they will give you question like N permutation R, and you need to solve something like that. know also that whenever they ask you n permutation have, it means reduce this n for like reduce it, let it be product of r times, yes, r times, that's just it. For example, 5 permutation 2, that's product of 3 times, starting from what? 5 downward. So 5 permutation 2, using this formula to that be 5 factorial over 5 minus 3 factorial, and that would be 5 factorial over 2 factorial. Okay? Now try rewriting this one up to 2 factorial. I told you if you are not getting to if you are not getting to 1, you should still put what? Factorial over 2 factorial. So this 2 factorial cancel this 2 factorial. And what do you have? 5 times 4 times 60, and that's what 60. So instead of going through this process, so just say 5 permutation 3 is reduce 5 up to 3 times. That'll be 5 times 4 times 3. It's better. I don't mean 3 like this. So 3 as in 1, 2, 3. Do you get that? That's 60. Okay, I believe you understand that. This one too is simple. I believe you understand. If you understand, please say hi. Okay, thank you very much. Thank you very much. Akindoyin Akinlade, you're welcome. Abibi, Abibi Alabibi, you're welcome. Shegun Hussein, you're welcome. You don't understand? Okay, let me do one more example. You get it. It's a very simple thing. Very simple thing. Look at this. You have 7 permutation 4. 7 permutation 4 will be reduce 7 up to 4 times. Okay. 7 times 6 times 5 times 4. That's how many? 1, 2, 3, 4. It does not mean you should stop at 4. Okay, let's do this. 7 permutation 2. Reduce 7 up to like for 2 times. That is just 7 times 6. 1, 2.
Yes.
So it does not mean that you have to reach 2. No. It means by counting 1, 2. By counting 1, 2, 3, 4. Okay? So what if it is 8 permutation 3? That was 8 times 7 times 6. 1, 2, 3. And you must not jump any number. Okay? You must not jump any number. That is how simple it is. Okay? That is how simple it is. Okay? Now look at this. What if I say m permutation 2? Now the reason m permutation 2 equals what? 6. Now, and they asked us to find, they said if this, find n, or find n plus 1. Okay? Now n permutation 2 means reduce n up to what? Like 2 times. That would be n. When you reduce n by 1, you know that would what? N minus 1. Okay? This is your n permutation 2. This thing here is your what? N permutation 2. That is n multiplied by, reduce n by 1, n minus 1. These are many terms. 1, 2. These are n permutation 2. Equals to 6. Now, what do you do here? Most people will open this bracket. This is what they will do. M squared minus n equals 6. Then bring this one back here. Becomes minus 6 equals 0. And solve quadratically. N, the sum is plus 1. The product is minus 6. N minus 3 and what? N plus 2 equals what?
7. N equals 3.
Okay? Is that n equals to 3 or n equals minus 2? And note that this one here cannot be negative. And also, this one here cannot be more than
This one.
this one has to be more than I should have talked about that one. N is greater than or equals to R.
R.
But R cannot be greater than N. So coming here, N cannot be negative. Okay? N can and R
Equals. Doesn't.
are greater than 0. Okay? R can be equals to 0 too. But N cannot be equals to 0. Note that. So moving on, N is 3.
Let's see like that job.
Okay? N is 3. Now, putting it here, 3 plus 1, that was what? 4. But instead of that, some people already know it from here. You know what they will do? This one is consecutive number. N and N minus 1. Between N and N minus 1, which one is bigger? N. Because this N minus 1 is one less
One lesser than N.
Do you understand? So how do I write 6 as a product of two consecutive numbers? So that means I will write it as 3 times 2. If N is bigger here, what is bigger here? 3. That means my N is 3.
Three.
So instead of going through this
Yeah.
process.
We die.
Okay. If you understand, please signify.
Was shocked. Electric current. It is a girl.
Please signify if you understand. Okay, I think we got you understood. Who else again?
Understand.
Google at that. Yeah, they look at. You always see.
Allah BB, thank you very much. If you understand, say aye.
Aye.
Only 2 people understand.
I understand.
Nifemi, okay, thank you very much. Who else again?
Do it.
I don't sleep yesterday.
Please, if you understand, say aye, please. So I will continue. Hope it's not that you guys are sleeping already.
Jonesing.
Oh, okay.
Jonesing, man.
So if n is 3, then n plus 1 will be what? It's 4. That's 3 plus 1. So moving on.
Master. Is it good to be n plus 1 or n minus 1?
I said find n plus 1.
Oh, we find n plus 1.
Yes.
Someone is asking for another example.
Okay, another example. Okay, let's see.
Al-Abi.
It said if n plus 2 permutation 3 equals to n permutation 3 equals 24. Okay, and they said find n. N permutation 3 equals what?
24.
So what does that mean? It means you have to reduce n plus 2 up to 3 times. So n plus 2, reduce this one by 1. Now when you subtract, it becomes what? N plus 1. Okay? By subtracting 1 from 2, it becomes n plus 1.
Yes, sir.
Subtract 1 again.
And
From
that's
this one,
N.
that's n.
Yeah.
So it is how many now? 1,
2,
2,
3,
3. And that is equals to
4.
Good. Now, how can I express, instead of opening brackets and having polynomial, I start using triangle method. Express 24 as the product 3 consecutive times. Because all these ones are consecutive.
3 times
That's what? 2 times 3 times 4. Or you say 4 times 3 times 2. Good. So I can write it as n plus 2 multiply by n plus 1, multiply by n equals to what?
4 times 3 times 2
Okay,
over 1.
good. Now, it is n they ask me to find, right?
N is true.
N is the smallest. What's the smallest here? So n is equals to 2. If you understand, say yeah.
Yeah.
Is that your yeah? Is that your own yeah? Someone said you cannot spell.
I be a wide in the press.
TT, yeah. Okay, thank you very much. Okay, moving on. So, the question can come in that way. Okay, what if it is? They said, how many? Three-digit numbers
They told this one. This way,
greater than 300 can be formed using two digits. Okay, using 2, 3, 4, and 5. If repetition is not allowed. Okay, we're back to it again. 3-digit number. 1, 2, 3. Okay, 1, 2, 3. Now note that anything you're using here can only be what? 3 and upward. It cannot be less than 3. Because for it to be greater than 300, are you with me? It has to be what? A value
greater than
value from 3 or 4. Because can have 324. This is still greater than what?
300.
You get that now?
Yes.
So this one here can only take 3, 4, or 5 based on what you want to do. Okay, so this first one has how many options? 3 options. It can take 3, it can take 4, and it can take 5. But can it take 2? No. If the first digit is 2, it will be 200 and something, and that's less than what? 300. Okay? So 1, 2, 3, 4, 5. So we've taken 1 out of these 3. Remember what? Let's assume it is this 3 that we take. Now this one here now has how many options based on what we have here?
3 options.
You know 2 can be here. This is where 2 cannot be. But 2 can be here and it can be here. Good. So let's say it is even 4 we use here. So this one here will have how many options?
2 options.
So what's our answer? 18 times 3 times 2. And that's what?
18.
18 numbers.
Okay, I should explain again. Okay. Based on the question, it is stated that it has to be greater than 300, and it is also given that it is 3 digits. I will have 2, 3, 4, 5, and 4 digits. Okay? So, have 3 spaces.
Oh.
So the first one, for it to be greater than 300, 2 cannot be here. 2 cannot be here. For it to be what? Greater than 300. No number will start with 2. A 3-digit number. No 3-digit number will start with 2, and it will be what? Greater than 300. No. Do you understand?
Yes.
So definitely this one can only start with 3, 4, or 5. So that's how I you get that now?
Yes.
So let's assume we're using one of these 3, 4, or 5. Let's say it is 4 that we're using all together now. For this one, remember the reason why I'm erasing it is because repetition is not allowed. That's why I'm erasing it. I cannot use that value that I've used here. Okay? So we come back here. We say how many options will this have? That that cannot be here can be here. Because when you say 324, okay, the 2 is at the middle. Eh? And that 324 is still greater than 300. Okay? So definitely we include this one when we're counting the option 2, 3, and what? 5. It has 3 options. So let's erase one of the 3 digits again. Because repetition is not allowed. I cannot use anything we use here. So how many options do we have left now? 2. That is why this one is 2 here. I'll have an answer to 3 times 3 times 2. Eh? Allah, do you understand that? Ifemi, do you understand now? You guys should not forget to follow me on TikTok, Matt Ark, Adishegis Lima, if you cannot find out, and share it with your friends. And if you have anybody that is influential, you can take me to 1,000 followers. Yes, we'll be using TikTok, and I feel like that will be user friendly, to be more friendly than this. Okay. Look at this question. How many digit number? Okay, let's say how many number greater than 200 can be formed using 1. Okay, let's just say greater than 300. Using 1, 2, 3, 4, and 5. How many numbers greater than 300 can be formed using 1, 2, 3, 4, and 5? Repetition is not allowed. Okay, pending the time I want to give you my marker. You can try solving it. Let's see what you get. Yeah, Dagbit said 6.
Adibita said 6.
Location don't find one. Find the wood of paradise. The wood and white. She was
I can see him.
Who got 60? Alabibi got 24. Nifemi got 16. Adibita said she got 36. Nifemi got 60. Alabibi 24. Who else again, please?
What do you get? No, it's early. What do you get? 35. 35.
It's 5.5.
TT 36. Okay. Yeah, let's try it. Okay, let's try it.
Since I said, how many numbers greater than 300? Okay? Okay. We'll say 3-digit number. This one, what cannot be here? For it to be what? Greater than 300. Okay? You cannot have 1 here, and you cannot have 2. So you can only have 3, 4, or 5. So this one has how many options? 3 options. Okay? If one of the options is gone, for the second one here, you have how many options? 4. If 2 of it is gone, you have how many options now? 3. Good. But then, is this correct? I know this is what most of you did. To say you have what? 36, but it is actually wrong. Okay? What I said is that, how many numbers? I never said how many 3-digit numbers. So that means it can be 4 digits, and it can also be what? 5 digits. So this one here is for your 3 digits. Okay, let's do that of 4 digits. This is for 3 digits. For 4 digits. So for 4 digits, 1, 2, 3, 4. For if it is 4 digits, not automatically 4 digits. All 4 digits are greater than 300. So there's no restriction here. So this one will be what? It has 5 options. This one will have 4, 3, and this one will have 2. That is for what? 4 digits. For 5 digits, this one can be what? It has 5 options. 3, 2, and 1. So this one here is what? 720. What's that? 120. This one too is what? 120. Why this one is 36? So adding everything together, it means it is either it is 3 digits, or it is 4 digits, or it is what? 5 digits. So that will be 36 plus 120 plus 120. And that will be what? 276. Okay? I didn't mean someone get it right. I would have given.
Well, nobody got it. If you understand, please let me know.
I understand. Don't sleep, Johnny.
Thank you, Ala Bibi. Thank you for understanding. Who else again? Okay, TT, thank you very much. Aisha Babalola, please, can you explain it again? Okay. Yeah, please look up and listen again.
And the question is how many number greater than 300? Okay, I'll start with 3 digits number. For it to be 3 digits, the first digit, based on what I have 1, 2, 3, 4, 5. The first digit cannot be 1. Because 100 and something, there's no number that is 100 and something that will be greater than 300. And no number that is 200 and something that is greater than 300. So definitely this first digit is either it is what? 3, 4, or what? 5. That means it has how many options? 3 options. That is why I'm putting 3 here. Multiply by this second digit now. We call that there is no repetition. So any one of this one that I'm using, I cannot use it again. So let's assume it is 5 that I use here. So for this one here now, it has how many options? It has what? 4 options. Because it is only here that I cannot use 1 and 2. I can use it here. I can have 300 and 12. Do you get that now? That means 312 is still greater than
300.
So it is only here I can have my 1 and 2. My 1 and 2 can be here. And it can be here.
There.
So if I'm using 1 here now, okay? I've used 1, I've used 5. It means how many options for the last one? It means 3 options. That's why I have 3 here. So recall in the question, I never said it is only 3 digit number. I only said how many no. Based on this option you have now, it can be 3 digit number, it can be 4 digit number, and it can also be what? 5 digit numbers. But can it be 6 digit number? No. Why? Because I now have up to 6 digits. Okay, so for 4 digits, every 4 digit number are greater than 300. Even if it is starting with 1,000 or something, it's not greater than 300. It is. Okay, even if it is starting with 2,000 or something, it's not greater than 300. It is. So that one, there's no restriction regarding the first one. Maybe it is 1 or maybe it is not 1 or it is not. So you just see how many options I have 5 options for the first one. How many options do you have for the second one? 4. The third one, 3, because it is reducing the option as one value is taking that position. Also this one, we have 120. Now for 5 digits, the first one has 5 options. That's another thing entirely, like we're starting all over again. Okay, that's the minimum. Like we're starting, not that what we use here. The option we get to this one. Because we're starting all over again. So that means this one will have it has 5 options. If one of the values is used, this one will be having what? 4 options. One of the values is used here again. It means how many options for this next one? If one value is used here again, it means 2 values. And then they will have that. So that for this one it is 36. For this one it is 120. For this one it is 120. So that will be 36 plus 120 plus 120. That will be 6.
I hope you understand now. Who has that question? Aisha Babalola. Okay.
Since we don't have questions, let's continue. So another part I want us to take is the concept of even if it is even, or if it is stated that it is even, or if it is stated that it is odd, then how many even number? Okay, how many? Okay, 3 digits. Let me make it 4. 4 digits. Can be formed using 1, 2, 3, 4, 5, 6, and 7. If repetition is not allowed, how many 4-digit even numbers can be formed if repetition is not allowed? Using that digit 1, 2, 3, 4, 5, 6, 7. Good. 1, 2, 3, 4 digits. You can have 5 digits because it's already stated that it should be what? 4 digits. Good. Now we then say for it to be even, for it to be what? Even, automatically the last digit has to be even. Go and check all even numbers. Their last digit is always what?
Even.
Yes. All even numbers, the last digit is always what?
Even.
So for this 4 digit to be even, then we need to check on the last digit. That's the condition here. So the last digit needs to be what?
Even.
So what do we say? How many even numbers do we have here? We have 2, 4, and 6. So this one only have what?
3 options.
Just 3 options. As we call, there's no repetition. So if we should use any one of them, we'll come back here again. We are using one of those 3 values. We'll use one of them. Let's say it is 2 that we use here. So coming back here, remember there's no restriction on this point here. There's no restriction here. There's no restriction here.
Yes, sir.
This is only here we have restriction. So let's say we use 2 here. Like we use 2 here. You know it has 3 options. That's why it's 3. But the number we're using there, let's assume is so that 2 is gone. So we have how many options for this one?
6.
1, 2, 3, 4, 5, 6.
6.
Why did I not count 1? I did not count. I did not count 2. I did not count 2 because I said we're assuming that we'll use 2 here. I didn't we assume that we use 4. I did not count 4. I didn't know we assume that we use 6. I will not count
6.
You get that now?
Yes.
I cannot use the 3 values at the same time here. It's just one of them. So this one we have 6 options for this one. So if I use another value again, we use 1 and 3. Let's assume that we have how many left? This one will what? 5. We use 1 again. This one will what? 4. Multiplying these 4 together. This one is the same. This one is how the 3, 60.
This is still
If you understand, let me know.
I understand.
So let me change this question here to 4 digits, but odd number. Okay, and let this digit here be 1, 2, 3, 5, and 6. Okay, repetition is not what?
Loud.
Okay. So, 4 digits odd number. 1, 2, 3, 4. Okay? The restriction is that it has to be odd. That means the last digit needs to be what? Odd. Okay?
Yes.
So the last digit needs to be odd. So how many odd numbers do you have?
1, 2, 3.
5. That's 3.
3.
You get that now.
5.
Coming back here, if you use one of the first stuff,
It's not the
you have what? 4 values left.
4, 3, 2,
Then this one what? 3.
Master.
And this one what? 2.
7, 6,
I'm not start with any of it again.
22.
If we use 3,
If when you use 3,
Mm.
then you have how many options left? 1, 2, 5, 6. Why? Because repetition is not allowed. How many repetition is allowed? It is still what? 5. So not before. So
72.
he said
72.
72 number.
Calculator.
Okay, so I feel like that one is clear now. So look at this question. In how many ways can you arrange 4 things? In how many ways can 4 items be arranged taking 2 at a time? What is that saying? That's 4 permutations. What are they saying?
4 times 3 equals 12.
12.
Okay?
Yeah.
It's as simple as that. Okay, so let's say we have, I say, a code. A code is made. Okay, a 4-digit code.
Digits code.
A 4-letter code.
Letter.
A 4-letter code. 4 letters is made. How many possible codes? How many possible codes are there? How many possible codes are there? So since it is 4-letter code, that is 4 options, like 4 things, position is what we're looking at. Okay? So for the letters, for the alphabet letters, we have how many? We have 26. So I say this first one has 26 options, and this one has what? 25. This one has what? 24. And this one has what? 23. I should have put it that repetition is not allowed. Or let's say a 4 letter, a 4 distinct letter. Should have been in the question, sorry. A 4 distinct letter code is made. How many possible codes are there? So that will be 26. What is saying is that there's no repetition. That's the meaning of this distance. So we have 26 letters of the alphabet. At 26. Since repetition is not allowed because it is distinct, the next one will have how many options? 5. Anything we've used here, we cannot use it again. We'll have 24 options there. We'll have 20. So it is as simple as that. Okay.
See?
Now look at this question here. Yeah? Right? In how many ways can the letter of the word heaven? Okay, no. Havoc be arranged. Okay?
next week I will arrange the letters of the word havoc. Okay, we have one. Okay, we have 1, 2, 3, 4, 5. Are we?
Yes, sir.
And this one here has how many options? You see, it has what? 5. Remember, there's no repetition because you just have just a fixed letter.
Yes.
This one 4, this one 3, this one 2,
So
this
this
one
one
1. This thing is still the same thing as 5 factorial.
Yes.
That means we're taking all the letters at a time. Do you get that now? H, A, V, O, C. We're taking all at a time. That's 5 factorial, which is what? 120. Good. And what if in the question they tell us that in how many ways can 3 of the letters be arranged? If in the question it is in how many ways can 3 of the letter of the word apple be arranged? So what are they saying there? It means we are taking 3 letters at a time. That's the meaning. So what would that be? That would be 5 permutation 3. Do you get that now? And what's 5 permutation 3? That would be 5
times 4 times 3.
which is 60. I hope you are getting it.
Yes.
Yes, sir.
Okay. So moving on, if you understand everything I've been explaining, please say I or send love so that I will know that you are with me. Please. Thank you very much. Oluwakemi Odunyemi Alabibi, thank you. Adegite, thank you. Oluwakemi Odunyemi, thank you. Nifemi, thank you very much. Okay? Boom. Those ghost viewers, is it that they are asleep or what? Because we are 7-year-old. What? Okay, let me just continue. Now look at me. In how many ways can 4, okay, let me say 5 items be arranged if 2 of them are identical? If 2 of them are what?
Identical.
Meaning 2 of the 5 items are the same. So that's saying that we can make mistake thinking it is this one that will pick, whereas it is the other one. So we cannot differentiate between the 2. That's the meaning. They are identical. Anything that happens to this one is happening to this one. Do you get that now? So how do we do that? So normally we would have said 5 factorial because we are arranging 5 items. Now that we have 2 of them that are identical, we have to say divided by 2 factorial. We have to say what? Divided by 2 factorial. So that will be 5 factorial, which is what? 120. 5 times 4
Times 3 times 2 factorial over 2 factorial.
This comes to the
60.
and that's 60. Okay? Now, another good example. In how many ways can 3 blue chalk, 4 red chalks, and 2 white chalk be arranged
assuming the chalks are of the same size, okay? They are of the same size. Now, in how many ways can we arrange this? Okay, can you guys try it? Let's see what you get.
Okay.
So the 3 blue chalks, 4 red chalks, they are all of the same size. In how many ways can we arrange them? You guys should try it and tell me the answer. Who is done, please? Who is done, please? In how many ways can 3 blue chalks, 4 red chalks, and 2 white chalks be arranged? If the chalks are of the same size, who is done, please? Adigbite said 24. Okay, let's wait for others.
That's sleeping.
No sleep, too easily for that toilet.
Who else again, please? Okay, let me just give you hints on what to do. How many chalks do we have in general? In total, we have 9 chalks. That would be 9 factorial. Just the way I said we have 5 items earlier. So 9 chalks all over. You see those 3 chalk, blue chalks, they're identical. That's the meaning. That's why I put them as 3 blue. So that would be over 3 factorial, 4 red chalks, 2, 4 factorial under, and 2 white chalks, 2 factorial under. So you do that and you get your answer. Okay, so that will be 9 factorial over 3 factorial, 4 factorial, 2 factorial. So what do you get? What do you get? Okay, Nifemi, thank you very much. How come it is is it 12,660? Eh.
Okay, 1,260.
Okay. TT, okay. Banshee. Okay, Koniji. Okay, that's big of you guys. Okay, you are moving. So that is what happens in cases whereby I tell you to in how many ways can the letters of the word and the letters of the word
log within be arranged. If repetition is allowed, let's say this one repetition is allowed. Okay, let me put it this way. A, if repetition is allowed, and B, if repetition is not allowed. So for that one that repetition is not allowed, that is what we're doing earlier. We just say 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. Okay, so yeah, is there repetition of any letter? No repetition. So this one is B, and this is B9. But for the A, repetition is allowed. That means they all have, like all the positions, the 9 positions have the same option. This one has 9 options, 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 9 options. Because any letter that I've used it, I can still use it here. Any letter that I've used here, I can still use it here. You get that now? So that is why it is 9, 9, 9, 9, 9. 0 to 9.
9 is power 9.
So that's 9 is power 9. Thank you. So the
9
formula
to
for
9 to
that,
9 to 9.
whenever you have is to your call just now 9 and 9 places. Okay? 9 and 9 places. Oh, Lord, good. So if repetition is not allowed, it will just be 9 factorial.
Yeah.
Yeah, good. What is the question is? In how many ways can the letter of the word trigonometry be arranged? Trigonometry be arranged. Be arranged if repetition is not allowed. Okay, be arranged. Let's just say be arranged. That's the concept. Okay. So you then see how many letters were? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 factorial. But because we have repetition of some letters, those letters are identical. 2 factorial and 2 factorial and what? O 2 factorial. And that's the answer. So you just have to simplify it. Okay? So just check those ones that have what's it called? That the letters of your call. So you put this one under with respect to the number of times the letter of your call. Okay? So can you help me? How many ways can the letters of the word Ajishegiri, letters of the word Ajishegiri be arranged? Tell me your answer. I'm waiting. Ajishegiri. That was the normal thing. How many ways can they? That means the repetition cannot be allowed. Who is done in the comment section?
That's 60,000.
Who is done? What's the answer, please? In how many ways can the letters of the word Ajishegiri be arranged?
Last time they go into my name. Last time no is my name.
Please, who is done, please? In how many ways can the letter of the word Ajishegiri be arranged? Okay, what you have said 6,000, 60,000, 60,480 ways. Who else again? 60,480, TT 60,880. Wow. I feel like TT want to write 480. Probably it is. Yes. I'll do that 60,480. Good. So it is just as simple as that.
You see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial over. How many letters got repeated? I got repeated. How many times? 3 times. Over 3 factorial. I should have 60,480. Now let's move on to the concept of what if we want a letter to start? Okay, we want a letter to start. Okay, so still this question here. There are many ways can letter of the word additionally be arranged if it must start with letter A. So if it is starting with letter A, that means we already know the position of A. What is left to us is to arrange this G shape without any issue with A here. The letters left for us to arrange is just G-I-S-E, G-I-R-I. We already know the position of these A. That's the meaning. That's the meaning of that. If this one must start. They get that now. So and that will just be 8 factorial over 3 factorial. That's the meaning of if it must start with that letter. Okay? And also, if it is that if it must end, we tell that if it must, this one option, this another part must end in or with J. If it must end with what? Letter J. So that means we already know the position of J. That means what we just want to arrange is A-I-S-E-G-I-R-I. Do you get that now? So that one also is still what? 8 factorial over the I that appeared twice. 3 factorial. Now I want you to do this one for me, guys. If it must start with A and end with J. In how many ways can the letter of the word additionally be arranged? If it must start with A and end with J.
Oh yeah, I'm expecting the response from my audience, not from this physical. I'm expecting my response from my online audience, not from the physical living way. Yeah, I'm expecting if it must start with A and end with J. Different people will be able to join. That's one benefit of TikTok. Even those people that you don't know, you take it to them.
It's the count. What if it?
Touch that.
What if it must start with G and end with A
Torchlight.
I must be with
Torchlight.
you know you on. I don't have any. Come shade, come shade. I must have come on,
Please, who is done? Who is done? If it must start with A and end with J.
start with what I don't know. Master, what is
6,720. 6,720. Thank you. Please, who is Titi? Who is Titi? Do you know me?
Yes,
Did I know you?
Yes.
Are you me? It's me, you.
Thank you very much for joining my live, Titi. I'm expecting one more response. 8:40. Okay, so let's get the solvings started. Okay, I said if it must start with A and end with what? J. So that means we already know the position of A and J. We know it is starting with A and it must what? End with what? J. So the only thing we want to arrange are ISEGIRI. Should be what? 7 factorial over 3 factorial. Okay, that should be what? 7 factorial over 3 factorial. So what would that be? That would be 7 times 6 times 5 times 4. Okay, and that would be 10 times 28, which is what? 6,000. What's that?
640.
30 times 28. This should be 4.
Oh, yes.
6 to 8.
So,
840.
840, yes. Everybody, thank you very much. So the answer should be what? 840. I believe you guys understand now. We already know the position of A and J. So what is left for us to arrange is just what? ISEGIRI. Okay? Do you understand that?
She said she knows you.
Okay, who didn't understand?
She said she knows you. Titi.
Okay.
Never met her before.
It's not even it's a man now.
Okay.
Man.
It's a guy.
T-boy.
T-boy, yes.
Titi.
T-boy. So Taiwo. Taiwo boy.
So factorial is 54. 50.
Okay, in how many ways
Alpha.
can the letter
Specific is capacity of ice.
of the word of the word
Aluminum.
let's say of the word horizontal, or what should we say?
900. Copper.
Building.
Brass or copper. Copper is not
Be arranged. How many ways can the letter of the word building be arranged?
give us 100.
If it must
Paraffin or unicorn.
start with
Unicorn.
B and end with G.
That's too far.
Silver is 234.
Yeah. You guys, let me do that.
26.
And the next one, a building.
Two
If
factorial plus 6 factorial plus 4 plus 3 plus 4
it's must
Shall this over?
start, must begin it must end with okay, if the last three digits is the
last three letters. The last three letters are D, N, G.
2, 9, 6, 7.
Okay, I believe you should be able to do that A and B. For that A, I'm satisfied you guys will do it. Okay? In how many ways can the letter of the word building be arranged? If it must start with B and end with G. Just like what I just finished explaining. So, and the next one, if the last three digits are D, N, G. In how many ways can the letter of the word building be arranged? If it must start with B and ends in G. If Femi said 360, you mean the first one, right? Okay, very good. If it is the first one, that's correct. Because we have just U, I, L, D, I, and N to be arranged. And that's 6 letters. That will be 6 factorial. All over, yes, we have I to be repeated. I is repeated twice. That's over 2 factorial. So 6 factorial is 720. Over 2 factorial, which is 2, is 360. You're correct on that one. So for B, the last 3 letters are D, N, G. I said 60. Okay, let's wait for others.
There's no others. I'll just.
You guys open that from there first. I really thought some letter B.
You don't hear.
Sharp guy.
Okay. Yes, I understand. And that, yeah. So right there I said 360 and the second one is 60. Good. Okay, let's wait for others. Okay, TT said 360 and 60. Okay, let's get to work. I believe you guys, you all can do this. You all can do the first one. The second one, let me just draw more on that. So, if the last 3 units are D and G, now you need to be very careful. The last 3 digits, I'm not saying, it may be that, sometimes it may be that just the last 3 digits should be D, N, or G. This one also may need to be arranged.
NDG.
It can be NDG, it can be G, ND. So you may have that one to be 3 factorial, but let's leave that case out of this. So we'll have how many letters to arrange? We'll have taking out D, N, and G. We'll have 1, 2, 3, 4, 5. That'll be 5 factorial. Over I is being repeated 2 factorial. 5 factorial is 120 over 2, and that was 60. But I think this one also should be arranged. That would have been 60 multiplied by 3 factorial.
Yeah.
And that's what? 6 times this, that would be 360 as well. Okay? Okay, moving on. Look at this question. In how many ways can the and 3 letters and okay, let me see, now 4 letters.
It's connected.
Okay, it's just repeating. Okay, let me explain that part again.
So I said F, R, and what M. They are not included. So we're only arranging the letters of the word M, N, O, A, T, I, O, N. Okay? So that's 8 letters. But remember, it is 4 letters that we're taking at the time. That was 8 permutation. 4. And recall that I occurred twice over 2 factorial. N occurred twice, 2 factorial. And O also twice over 2 factorial. Okay, so 8 permutation 4 will be 8 times 7 times 6 times 5. Like you reduce it up to the product of 4 times. And this 2 factorial is 2, 2 times 2 times 2. That's 8.
Sorry.
This cancel this. The answer should be 210. Okay?
Miss.
210. I hope it's clear.
Yes, sir.
Now, what if the question is? What if the question is? If it must contain F, R, and what? M. Okay? If the question is if it must contain, we are reading 4 letters. We are taking 4 letters from this. It's just like that question is seeming like what's it called? Combination, like selection. Let's leave that one out for now. Let's rule that one out for now. So when we get there, we'll know how it will be done. Okay? Yes. In how many ways can the letter of the word biology arranged if the 2 O's must always be together. And if the 2 O's must always be together. Now this is what you do in this sense. Be very careful. You say B, I, X, G. When the 2 O's, count them together. Yeah, good. So these 2 O's, we're counting them as what? As one. As one. We should have said 1, 2, 3, 4, 5, 6, 7 factorial over 2 factorial because the O got repeated. Because they said the 2 O's should be together, and we count them as what? 1. Because anywhere the first O go, the second O will fall below. Letters we have now. See 1, 2, 3, 4, 5, 6. That's 6 letters. 6 factorial. Yeah. Are you getting it? So there is a over. Okay, sorry, there's no over. I'm sorry. 6 factorial because there's no repetition here. I don't know if there's a repetition here, we'll take over. But there's no repetition here. Then we'll move on to this one. I'll say arrange this one. In how many ways can you arrange this one? That means we have 2 letters. Over 2 factorial. How we divide by 2 factorial again? Because this letter already got repeated. So this one cancels this, and our answer is what? 6 factorial, which is what? 720.
Miss.
Okay, moving on. In how many ways can you arrange the letters of the word unicorn? Always be together. So we'll say
5.
U, I, C, O, R. Okay, U is that's U and N together.
That's 5.
Now let's count. How many letters? 1, 2, 3, 4, 5. Say 5 factorial. Look at this one. Is there repetition? no repetition.
Three.
Then we move on to this.
Three, yeah.
How many letters? Three. Okay. Look at it. Is there repetition?
Yes.
Yes, there's repetition.
Over
So over 2
factorial.
factorial. 5 factorial is what? 120.
120.
Abi? 3 factorial is 6.
6.
2 factorial is 2.
Two.
You have 3.
Eight.
And now 3,
360. Yes.
I believe that is clear.
Yes.
Okay, let's look at the word. In how many ways can the letters of the word fantabulous? Can someone let me spell fantabulous? Fantabulousl.
I just face one.
If okay, if Fanta must always be together. If Fanta must always be together. You guys should do that and tell me your answer. You guys should do that and tell me your answer. If the Fanta must always be together.
I know Fanta. So, 2 factorial over 2 factorial times 4 factorial over 2 factorial. Over 2 times 1. 4 factorial is 50, 40. Over 2 factorial.
What is it?
That will be 25, 20.
What is it?
7 factorial is 50, 5,040. Divided by 2 will be 25, 20. Times 1 over 5 factorial. That's 120. Divided by 2. That's 60. 25, 20. 25, 20 times 60.
40 by 3. That's 1 5 1 2 0 1 5 1 2 0.
Please, who is done?
Done.
In how many ways can the letters of the word fantabulous be arranged if the Fanta must always be together? If the letter F-A-N-T-A must always be together.
No. It can leave camera roll.
It is not founded.
Where will this one?
1 2. Charlie.
Okay, thank you, Adura. Okay. That's tech, bro. Thank you very much. You said 360. Okay.
Like I stop in. Like
Who?
Adura.
Okay, now this one like that. I don't know.
I dig with 151,200. Okay.
Yeah, 1 5 1 2 0. I mean 1 5 1 2 0.
This is right.
TT 302 400.
Okay, let's get it solved.
So we'll see.
That matter you do.
Fantabulous. The Fanta is always together, so we'll still count this one as what? 1, 1, 2, 3, 4, 5, 6, 7. That should be 7 factorial. When we look at this one, is there any letter that is being repeated? Yes. The U got repeated twice. But with 2 factorial. Multiply by, we'll then come back here. How many letters do we have here? 1, 2, 3, 4, 5. That's 5 factorial over, is there repetition here? The A
Yes,
got
sir.
repeated twice. That is 2
2 factorial.
factorial. So answer will be 7 factorial times 5 factorial over 2 factorial to factorial, that's 4. So you can do this one.
This game is
You get your answer.
151200.
1, 5, 1,
1200.
1, 51.
that game is not that far.
Okay. So for those of you that don't understand, this is how you go by it.
But never really look old or like.
You first of all separate this one. You start it as 1, 2, 3, 4, 5, 6, 7. 7 factorial. Because you got repeated twice there, see 2 factorial times, you then come back here. How many letters do you have here? You have 5 letters over A got repeated twice. Then we'll have an answer.
Okay, so
Thank you very much. Now we are moving on to that part that the
Shall
letter must never be together. The letter must not be together. Is that in how many ways?
You fit do one.
Can the letter of the word elation be arranged if CION should never be together. So whenever you have questions like this and they say should never be together, that is they should not be together. In the line. They should not be together. So what you do is that you do the normal thing that okay, in how many ways can I arrange the letters of the word elation normally? And say minus if the letter that they said they should not be together should be together. So the concept is just the concept of the universal minus A gives A prime.
Yes.
Okay. So you do the normal thing, elation. In how many ways can you arrange the letters of the word elation? 1, 2, 3, 4, 5, 6, 7. That is 7 factorial minus if the shun are together, the letter TION are together. Okay, what would that be? 1, 2, 3, 4, 4 factorial. Is there a repetition here? No. Multiply by how many letters do you have here? 1, 2, 3, 4. Another 4 factorial. So answer will be 7 factorial minus 4 factorial times 4 factorial. Okay? So that's about that. 7 factorial is 5,000 and 40. 4 factorial is the what? 24. 24 multiplied by 24.
6. 1,
that not 576? No. 676.
96, 576.
So we then subtract this and we'll get an answer. Okay? Now, look at this question. In how many ways can the letters of the word fearless fearless be arranged if E and SS should never be together. Should never be together. Okay? It's still this concept we have to use. We say one. In how many ways can we arrange this normally? 1, 2, 3, 4, 5, 6, 7, 8. That will be 8 factorial over repetition, yes. E twice, S twice, minus if the EEAS are always together. That means this and this are always together. So we'll count them as what? 1. So say 1, 2, 3, 4, 5. I've already counted them, so I will not count them again. That's 5 factorial. Now look at the remaining ones. Is there repetition? No. And say times. Okay?
4 factorial.
Now, here now, how many letters do we have here? 4 factorial. Over, is there repetition?
2 factorial.
2 factorial.
2 factorial.
Okay, so I'll be 8 factorial minus 5 factorial times 4 factorial.
Yes.
So our 8 factorial should be what? That's 40,320. 40,320 minus 5 factorial is what? 120. Okay? Then 4 factorial is what? 24. This is 8, this is 4. This is 4, this is 2. That's 288. That's 288. Over the LCM will be what? 4.
Yes.
So subtract that one and divide it by 4. So this is case whereby we talk about if something must never be, so a so letter must never be together, if they should not be together. Okay?
Yes,
and it
sir.
can also come in form of word problem. Here you add it to be, okay, we want to arrange 10 people. In how many ways can let's say 10 people be arranged such that
Black.
a couple must always be together, must A always be together, B never be together. So for the always be together, that means you count this couple as what? As 1. So that means how many people are we arranging? It should not be 10 people anymore. It will be
9
It will be 9. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're counting these two.
Yes.
As 1, 2, 3, 4, 5, 6, 7, 8, 9. That means we're arranging 9 people.
Yes.
Do you get that now?
Yes, sir.
Now say multiply by, in how many ways can we arrange these two people again? Are they identical? They are not identical. So they are only 2 factorial. Do you get that now?
Yes.
That's first one. The second one, if they must never be together, remember I told you that the universal minus A is equal to what? A right. So what would we say? The normal thing, normal arrangement of 10 people was what? 10 factorial. Minus if they must be together, that will be 9 factorial times 2 factorial. And that's answer. Okay?
Yes, sir.
So
Only this one.
In how many ways? Students
Google let you
be arranged
One person.
if three brothers be arranged on a team. If three brothers must never be together
I will switch factor.
or should never be together.
Oh wow. Yes. Yeah. Minus. Do you counting that one? That's 4 factor. Okay, my number is together.
So we have how many students? 6 students. Since they said never be together, that means not. Now we use the concept of u minus a equals what?
A prime.
Prime. What's the universal?
6 factorial.
6 factorial minus if the three brothers should always be together.
That's you.
That means apparently the three brothers has
Yes,
one.
that's 4 factor.
So say instead of saying 1, 2, 3, 4, 5, 6,
6.
the three brothers are together. That's how
Minus
many?
4.
1, 2, 3,
4.
4 factorial. So go back to the three brothers. Now how many ways can you arrange them?
3 factorial.
Ways. And you
Are
subtract.
they identical?
This one here is what?
Are they identical
720.
triplets?
20.
Identical
4
triplets.
factorial is what?
24.
24. And that one is 6. Yeah. 4, 2, 4, 140. 140. And you get your
Master.
answer.
Master. What if the brothers are identical triplets?
Okay, if they are identical, if the brothers are identical, so here now we have to say divided by 3 factorial. And even here it should have been over 3 factorial because they are identical. Okay, we have just one person here, so I'll be ending the live.
One person.
Just one person here.
Jesus.
I'll be ending the live.
And who's that person?
What is the time? If you are here, please say hi. Let me know the person I have here. Okay. Wow. So let's call it a day. Thank you very much for your time on permutation. Wow. TT is here. TT. Okay. Aduga is here. Who else again is here? Should I end the session and we'll continue combination tomorrow?
Yes.
We need rest button.
I should not end, Abby. TT, I should not end. I should not end. You want me to continue? Say continue. You want me to continue? Say continue.
Continue.
You want me to continue? Say continue. Okay, so that is that regarding that. Now, what if it is cyclic arrangement? That is arrangement around the circular object. Okay, arrangement around the circular
Objects.
cyclic arrangement. So whenever we are arranging around Example that object. Okay, the formula is just what you should know. The concept is that so arrange around the circular object. We don't know because it is a closed end. We don't know where to start
From.
Yes, that's the meaning. So we then put someone. That person will be standing as what? As the starting point, and also whenever we set back, we know that we've gotten to the end. Okay. So we then say this person position is fixed. Okay, we are not arranging it. It is others that we are arranging. So if we need to arrange n people, definitely it is round the circular object. Definitely it is not n people are arranging. One of them will not be arranged. Then it remains how many people for us to arrange? N minus 1 factorial. Yeah. Do you understand that? So
if I read the comments this way. Let's finish combination today.
Bernard Niel.
So let's continue.
n minus 1 factorial. That's the formula for cyclic permutation. Arrangement around the circular. Now, yes, if moving rightward is equal to moving leftward, like we are moving like this, is equal to moving like this, then the formula will change and it becomes n minus 1 factorial over 2. Why is it like that? It is because the rightward movement is equal to the leftward movement. Like there's no difference. Okay, so we have to reduce it because that's a repetition. So a good example is for things that are turnable, for turnable objects, just like beads. Okay, just like beads, threading what, beads in what, fishing, like, do you get that? The formula will be n minus 1 factorial over 2. So you can be asked that in how many ways can 6 students sit around the table? Sit round a table for dinner. So that will just be what? Is this 6 students who are arranging? It is actually no. Put 1. Are you with me now? And the remaining is what we are arranging. So we are arranging 5 people in short. So how do you get that 5? 6 minus 1 factorial. And that will be what? 5 factorial. That is 6 minus 1 factorial, which is what? 120. But if the question is, in how many ways can you thread? In how many ways can 6 beads be threaded in a fishing line? So what would that be? That would what? 6 minus 1 factorial over 2. And that would be 5 factorial over 2.
That is 120 over 16.
So why is it like that? It is because there is repetition. There has been repetition. Okay? What's the how many repetition? Just 2. Abina, moving like this is equal to moving like this. So we have to divide it by 2. Okay? This kind of question can then come in another form. Which form will it come? Look at. If you have something like this, you've known the situation whereby you tell that some things are together. Okay? We have that situation. You already know that one. So what if the question comes like this, that in how many ways, okay, let's say there are 6 students and 3 teachers in a party. In how many ways can they be arranged can they be arranged on a circular table? always sit together. Now, listen, there are 6 students and 3 teachers. So that means how many people we have all together?
9.
We have 9 people all together. Now, when we're arranging them down the circular object, automatically it is not like people are arranging. It is how many people are actually arranging? 8. But then he said the teachers should always be together. And you remember the concept of being together, meaning you regard to them as how many? As one. There won't be, those teachers will not be 3 again. You regard to them as what? 1. Okay. So we say we have, normally we subtract 1 from it. We say we are arranging 8 people and not 9. And this 8 also, the 3 teachers out of this 8, let's subtract 3 from it. That means we have 5. And those teachers will regard it to them as how many? 1. So that means we are arranging 6 people.
Yes.
16. 1, 2, 3, 4, 5, 6, 7, 8.
3, 1.
Okay? The 3 of the teachers are regarded to what? As 1. 1, 2, 3, 4, 5, 6. That is 6 factorial. Do you get that now?
Yes,
So move on to the teachers. In how many ways can you arrange this teacher? That will be 3 factorial. So our answer was what? 6 factorial times 3 factorial. Okay? But if the question is, if the teachers must never be together, so that will just be what? 8 factorial minus 6 factorial times 3 factorial. Okay? So that's about that.
Guy now.
Yes, it can also come in form of if they are directly opposite to one another. Okay, let me tell you that in how many ways can 6 girls be seated around the table if a girl must sit directly opposite
They're coming for you.
another girl. In how many ways can 6 girls be seated around the table if a girl must sit directly opposite another girl? So that means the arrangement will not be that. How many are we arranging? Normally it is around the table, so it will not be what? 6. It will be 5. Good. Now, out of those 5,